Well, thanks everybody. This is way more people than I thought was going to show up, given that you're all breaking rule number 19 for PSU MacAdmins. If Mikey Mike is giving a talk, you go to Mikey Mike's talk. Well, Mikey Mike is giving a talk right now down in Dean's 1, but I guess you can't necessarily. Or Dean's Hall 2, actually. So not everybody can fit into there. But he's giving a little chat on reverse engineering the OS, a practical guide. There's actually 4 people there. Mikey, Mike, Pudquid, Brogger, and Michael Lynn. All of his different aliases throughout anything. So when I actually found out the schedule for this, I was really bummed because his was the one talk that I wanted to see. No. So that's why I was, yeah. So the Mac Mule, he's just like, well, surely you should automate your talk, and I was like, wow, and mic drop. And so I was just like, oh, well, that's brilliant. So that's what I'm gonna do. Let's see here. Where am I? Boop, boop, boop. All right. Let's. And full screen. Cool. See you guys later. All right. Okay. Maybe. Unless everybody wants to go there. In that case, we can just shut this down and go over there. And bring that back up. Okay. So what's the plan? Most of you know this is a talk on continuous integration, and a lot of the stuff that we've written is in Python. So I figured, I guess you can see that a little bit. So the plan here is this Python function. First, we're going to talk about what is CI, and then a little bit of Jenkins CI. We're going to talk about some of the CI tools and how we use CI at Square. And so we're going to loop our way through that. And then we're going to tell a little story about why we built this particular tool. And then we're going to do a Q&A session for that particular tool. And then let's actually hurry this up so we can all go grab some beer. End of the day, I'm sure everybody's a tad thirsty. All right. So yeah, anywho, this is a continuous integration talk, an automation framework for MacAdmins. So I came up with that title months ago. And since then, I don't really like it anymore. So it's pretty much just a DevOps talk for MacAdmins. What is continuous integration? Who here knows what continuous integration actually is? Wow, okay, I can see why you're here now. Great, no, this is perfect. Continuous integration is actually a common DevOps practice. It was originally designed to avoid what developers called integration hell. And I'm actually going to use this example over here from my good buddy Nick McSpadden earlier, which I just happened to find like 3 minutes ago was still up here. So say developer made branch A, and then another developer made branch B, like a feature, and then they tried to merge them in around the same time. Integration hell, like it just, things don't work well. And so that's why people wrote continuous integration, a way to build, test, and deploy these new features together in a streamlined process to get them out the door. And I'm sure you're probably all thinking, well, why do I need to do any of this with Mac stuff? Well, that's why we're here. We'll get into it a little bit later. So there's some common terminology for continuous integration. The few of the buzzwords you'll hear around it is CI, which is continuous integration. And then there's CDEL, or I think that's how people pronounce it, which is continuous delivery. And then there's continuous deployment. All 3 of those things are different. How are they different? Well, I found this lovely little graph, thanks to Amazon, that explains it quite well. So continuous integration is this first step here, where new changes are made via normally source control. And then they go into a build phase. So you test whatever was recently made and however the normal build process is. And then that's actually where continuous integration stops. So, I mean, we could pretty much call it a day if we wanted to, but I mean, we've got a few minutes, so why not carry on? And then this is continuous delivery. So continuous delivery loads it up into the staging process, and that's where you run a little bit more integration tests and some load tests if you want. And then if those changes want to go on any further, they have to be reviewed. I mean, they have to be approved by an actual human, and then the changes can go out. So that is the only thing that differentiates itself from continuous deployment, where that last step is fully automated, and out the door it goes. New feature, you get a new Facebook Messenger or a new Slack version without anybody having to do anything, and that's probably why things break all the time. There are a ton of different CI tools out there. This is the new big fad in DevOps over the past couple of years, and people are, building products left and right to do CI. Circle CI is one of the newer ones on the scene. They're doing some pretty good stuff. We looked into it a little bit. Travis CI is pretty popular in the GitHub community, mainly because it's free. Amazon has its own pipeline that you can do. CodeShip is a whole another one. We've got Jenkins, which we'll talk about in a little bit. And then there's also GitLab, which is basically GitHub with a little bit more like CI built into it. So Mac Justice is actually in the room. Woohoo, right over there. He's going to talk tomorrow about GitLab and this kind of stuff. So if you're here, you probably want to go there. So yeah, tomorrow, 10:45 a.m. So like I mentioned earlier, we use Jenkins. So before we get too into talking about anything about Jenkins, let's go into the origin story of Jenkins. So Jenkins was actually originally called Hudson, and it was built in the early 90s, I believe. And it was originally developed by Sun Microsystems, and then Oracle bought Sun Microsystems, and they wanted to commercialize it and have their way with it. And the original developers of it didn't want anything to do with it. They wanted to keep the way it was, nice and open source and friendly for everybody. So they forked it, and they called it Jenkins. Okay, but what actually is Jenkins? It is an open source automation server that mainly operates around version control. It handles version control really well. Git, Mercurial, you name it, it's a version control system, it uses it. You can trigger different activities in Jenkins via commits. So if anybody adds, makes a commit, it has a cron style option. So you can be like, okay, run Monday, Tuesday, and Wednesday between the hours of 8 and 4 o'clock every 30 minutes. That's possible. You can also you can use a URL in order to do an HTTP post to it, and you can start a job like that. One of the big features and the niceties about Jenkins is actually the fact that there are plugins, and oh man, there's a lot. There's thousands of them actually. If you can think of a reason or a way to use Jenkins, someone's probably already made a plugin to support it, which is great. It's all on one single site that you can download them from. They all update in there, and you can go from there. And the big draw for us was if you can script it, if you can generate a script, you can have Jenkins run it. So it's up to you. Jenkins is as flexible and it can go as far as you can dream up and as far as you want to go. So these are like some of the reasons why we initially went with it. Plus, because one of the guys that knew a lot about it that I used to work with, he decided that I'm going to stand up Jenkins, and that's what we're going to use. So that's mostly the reason why we started using it. But how did we actually start to use it? It all started with our good friend that many of you probably know, Munki. We wanted to put Munki on the internet. So if you got outside of the corporate network, we wanted Munki to still work. And we had a big corporate infrastructure, and nobody put anything out on the internet. It was the whole, well, if it's on corp, it's safe. But, you know, thanks to Google and a lot of their Beyond Corp initiatives, I believe Pine did a talk earlier on Beyond Corp stuff. Really good stuff. So when I first wanted to do this, this was pretty much me. I was just like, how am I going to do this? I talked with, it eventually escalated into this. It's like, I don't even know how I'm going to do this. So I was actually talking with a good friend of mine, Sam Keeley, who he was one of the big proponents for putting Munki on the internet. And we kind of figured we got something in place. But this was our normal build workflow. So a developer would make a change in Munki, push it to the Git server. If it was approved, and we would merge it in, it would go to our Munki build box, which is not actually an Xserve. Please don't use Xserves. We actually had like 9 or 10 of them. The original IT guy was from Apple, so like when he first stood everything up, it was a bunch of Xserves. I really wanted to take one home when we decommissioned them and make a coffee table out of it. Google that. It's actually really cool, an Xserve coffee table. But so we drew up a plan, and I probably could have found a picture of what we actually drew on a board like this, or on a little whiteboard in the office. But this is what we wanted it to look like. So we wanted to put Munki on the internet, but we didn't want to change anything about our current infrastructure. We just kind of wanted to add it as a second layer on top and send it out to AWS. So this was the vision. This was the dream. So whenever something's merged, then it goes to the internal build system, which was basically a box that would do a git pull, and then for the Munki directory, it would do an lsyncd. It would use lsyncd to send it to all the other boxes. So in addition to that, we're like, okay, well, we can just take the same info and we can send it up to Amazon. So let's, figured it would work pretty good. So let's get into how that actually worked. Our good friend Jenkins here. So this is the dashboard for Jenkins. I've, blurred out some of the more internal stuff, I guess you could say. So this is the name column, like the name of the job. So that's where, you can, this is Munki sync, or this is, ponies go to stables, or, whatever you want to call it. This is the status for the last job. So the blue is we ran successfully. The gray is I've never been run before. And we actually have a surprising amount of jobs on that board that have just never been run. Anyway. And then the W column is actually the overall status and job history. So the sun means like pretty much every single job that it has ever run is successful, like it's been good. You can see like the little cloudy icon down there in the middle. That means, okay, it's probably failed like once or twice in the past week or two. And then the storm clouds is, this is a terrible job, nothing's working. So in the bottom left-hand corner, This is a list of all the current builds that are running. And the name of the nodes that are like the Jenkins runners. So this would be the main one, the master that we use. And then one of the other boxes is actually currently running a job when I took this screenshot. So as you can see, that's a progress of a job that we call Reposado run, which we'll actually get into a little bit later. And that is the 418th time that job is run. So let's see what it would be like to create a new job in Jenkins and move this forward. So let's create a job. We'll just call it PSU monkey sync. Oh, hey, that animation worked. Cool. And in this instance, we're going to do a freestyle project. You can do, like I said before, there's so many different options with Jenkins. It can be a little overwhelming at first. My recommendation is to start small with something like a freestyle project and kind of work your way through it. So that's what we'll show today. Alrighty, and next one. So this is like the main general screen for a new Jenkins job. As you can see, you have the project name, you have the description, it syncs monkey. Probably could have been a little bit more descriptive. I would highly recommend doing that if you're on a team. Poor Matt, the other guy on my team, probably looks at this. He's like, okay, it syncs monkey to what? And one of the more important bits on this screen is restrict where the job can be run. So if we're doing something with monkey and packages, we are probably going to run that on a Mac box. For like autopkg or something, but in this case we're just building the Git repo, and that can pretty much be run on any platform. And so this is a box that we call filer. Don't ask me why it's called filer, it just happens to be there. And there is one node in that label. So you could have filer 1, filer 2, filer 3, filer 732. But this only happens to have 1. So if there are more, you can set it to like the label expression here, which is just filer. So that would say use all of the boxes that are in the filer label. Or you could say only run on filer 1. So this is where we set up the source control. And it's pretty simple. You just enter the URL for wherever the source control is, and then you can provide it a set of credentials to access it if needed. And then this is where you say build which branches you would like built. In our case, we actually have 3 different main branches for monkey. So you can make a change on one branch, for instance, dev, and not mess up master. So dev is like 7 or 8 computers in our environment. It's mainly people that develop on monkey. So it's basically a sandbox. So we can do whatever we want, and then we slowly move the changes up the branches as to not, completely destroy everything just by messing with one manifest. So whenever changes are made to these particular branches, if change happens on dev, alpha, or master, it'll build them. Any other branches, this job will not build and sync. So the reason why we chose Jenkins to do this is like the main guts of why we, what happens here. So this is the AWS plugin for Jenkins, and that name is right there. So this is the CloudBees Amazon Web Services Credentials plugin. So it allows you to take your credentials to Amazon and then have Jenkins use them. So this is where you can add a new set of credentials. And then this page is where this is where all the action happens in this particular job. So the first thing that this does whenever there's a change in the new branch of munki is it does a get-fat pull. So we use get-fat for all of the packages and DMGs in munki. It allows us to put all of that into source control. So if a new package is added, it'll run get-fat, which basically takes a hash binary in a certain location, and then it rebuilds it and turns it back into its normal state. And then from there, this is the bread and butter. So and I probably said that like 3 times already. The AWS command line tool is a tool that you can use to interact with Amazon. And in this case, we want to sync things to S3. It's a little backwards, but it's S3 sync here. It's basically the same thing as rsync, except it works really well with Amazon for syncing things to S3. But the command line usage is very similar to that of rsync. This little bit, --cache -control, max -age equals 1, it applies a header to the files when it sends it up that basically says, keep this in a cache for 1 second. So if we make a change a few minutes later, the new changes will actually happen whenever clients go to reach out and pull items down. This section, --exclude, which I'm pretty sure most of you know if you have ever used rsync, basically says don't sync this bit whenever we do the sync. So if it's .get and forward or after, don't sync it up because we don't need to put the actual get information up on S3. And then this is where you send it. So from the current working directory that we're in, send it to the S3 bucket, and then get branch here is actually an environment variable. So that way it's just a one-liner that you can run. So it works successfully with no matter what branch you're currently running. It's magic. And they make it pretty easy to see the list of environment variables there. So you can just click on it and view them. I actually don't think I made a slide for that. Probably should have, but there's a whole bunch of different variables like the Jenkins job number, the build URL to it. You can get pretty fancy with whatever you're trying to do. And then at the end here, built-in Slack notifications. So we only chose to be notified whenever anything fails. So for us, no news is good news. And you can see where the notification would come back. So this is what we had for a little bit. And then once we got it working, everything was working really well. Changed things around. So everything goes straight to Amazon now. And if it's a bigger office that we have, you actually, we repurpose those X-serves to now they're Nginx CloudFront cache boxes. So if you look towards that box, it'll look to see if it has the item that you're requesting. If it doesn't, it will look to Amazon CloudFront for that artifact or that item and distribute it accordingly. So you don't have to have all the space necessary on your hosted boxes. You can, like, if your whole munki repo is 400 gigs, you may set it to only use 100 gigs, and then it'll just keep the newest ones there with the Nginx CloudFront cache, which is pretty nice. So this is munki sync. Does anybody have any questions about this particular process? Cool. Hello? Check. 1, 2, credit card. You're first. There we go. Ooh, coffee there.
I'm a noob at this. I'm not a developer. I'm just wondering if you could explain to me, like I'm 5, what kind of things do you develop and build and push changes? What are those things?
So, like in regards to Munki?
Right.
Explaining what Munki is. It's you distribute software with it, and it's really great on the client. I'm not going to go into like fully explaining what it is, but basically, what it builds is Chrome packages or Sketch packages or Parallels or whatever we have, and then Munki is basically just a stupid web server, like on the server side, and it just hosts a bunch of like flat files, which are basically p-lists. And then from there, like that's basically the instructions. I'm probably doing a really terrible job of explaining actually what Munki is right now. For anybody that actually knows what Munki is. How many people know what Munki is? Okay, and how it works? Okay, cool.
Awesome.
Yeah.
Munki is awesome.
Munki is awesome, sure. I actually have another slide with something like that later in the deck, but we'll get there. Yeah.
I think the thing that I was also getting confused by was develop versus importing packages into Munki and stuff like that, and just using command line tools. I think that was the confusion versus like developing code or developing it, building things yourself and putting those into Munki versus like importing stuff.
Okay.
And like autopkg and stuff like
sure.
that.
We'll get into actually more detail about that with CI stuff a little bit later. Anything else on Munki CI? Oh, I actually forgot to mention. So questions are free. Statements are going to cost you a beer later. So can you hand me the box and then we'll throw it back there, I guess. This is not going to go well. Yeah. Let's just have some fun. Oh, sports. Yeah. That is way better than the last time I threw that.
So when you've got your repo on in Git,
Mm-hmm.
and your developers that are working in your Munki repo are getting ready to release the latest version of software, are they forking the Git repo down to their individual workstation?
Yes.
And then at that point can use the GUI tools like MacAdmin?
Absolutely. Yeah. So that's actually like primarily what we do if we interact with Munki.
So do I owe you a beer? Is that a statement or a question?
No, that's a question.
All right.
No, I got your beard. We'll do it that way. That was the first one.
Gotcha.
Specifically about point of clarification, your repo is hosted externally accessible from your clients outside of your network?
Yes.
Okay. Do you do any kind of authentication and or do you have any kind of sanitization process during your automation queue to take out anything that may be proprietary to your internal stuff, or is there nothing pretty much internal hosted inside your repo?
So anything that we have in Munki is pretty much either a way to tell the computers update Apple software updates, like install them, which like I don't care if you see those files, and then and pretty much anything else is like it's just an easier way to get to Chrome or certain software that we want to make sure is updated. At first we weren't authenticated because we didn't care. There was nothing secret or private, so everything was just straight CloudFront. You could go get it. We actually developed a method where the initial Munki request goes to an EC2 instance that then does validation that we have and then does assign URLs to CloudFront. We're working on that to try and get that open source so people can use it. Pretty neat stuff, but does that answer your question?
Yeah, for sure. Thank you.
Cool. Awesome. We'll do one more on this and then we'll proceed, because this stall tactic that I had is working way better than what I thought it was going to.
Hey, my question was,
Sure.
Do you guys commit your built binary packages to your Git repo, or do you push those up to S3, like an S3 bucket? Does that make sense?
Yeah, so how the binaries and the packages and stuff works like that is that's where we use git fat. So git fat basically takes a hash out and then makes a pointer to it that basically contains information to where the actual information for that package lies on the server. And from there, once it hits the Jenkins, Jenkins, that's where Jenkins does the get fat pull. It looks for anything, and then it restores them. So I can show you a little bit later about what like get fat actually looks like. I'm surprised no one's really done a talk on get fat or anything like that yet. If you do you know who Alistair is? Go ask him about it, and then watch him go on a tangent about it. Love you, buddy, if you're ever watching this talk. So, perfect.
Thank you.
Yeah, absolutely. All righty. Oh, I might have to speed through this. Or maybe we'll hold a final Q&A at the end. All right, Reposado. This is a tool that we wrote that is continuous deployment for Reposado. Who knows what Reposado is? Cool. If you don't know what it is, we'll get there. So there's a little story behind this tool that we wrote. On December 8th, 2016, we decided to set a force upgrade for every single machine that we had to 1012. And how we did that was with our good friend Munki. Doing force upgrades or force installs of any nature, awesome. It went really well. We had the entire fleet of roughly 3,000 computers by December 8th on at least either 10.12.0 or 10.12.1. It went so well that this is basically what we felt like doing. It was fantastic. So then December 13th came around. 5 days later. It's great in San Francisco. It's great. Clouds were rolling in. I was brewing a fresh batch of coffee. And some dude was commuting to work. So I'm pretty sure that's a boosted board with like a piece of cardboard on top of it. If you don't know what a boosted board is, it's basically an electric powered longboard. But something else happened that day. Does anybody know what happened on that day that hasn't seen this bit of my talk before? Anybody? No? No? 10.12.2 came out. So this is what our firewall looks like on a normal day. Just a little bit of traffic, all is well in the world, nice and peaceful. We have Munki set to run once an hour, like it is by default. And when it runs every hour, it checks to see if there's any available Apple software updates. If there are, it tries to download them and cache them so it can prompt you and say, hey, you have an update. Would you like to install it? We had 3,000 machines, fresh, like on 10.12, went out to get 10.12.2. And it was basically a snowball effect. And that's actually one of my favorite GIFs, by the way. And then this is what our firewall looked like. Even though this is a bunch of water, it pretty much caught on fire. But it didn't actually catch on fire. The NetEng team came running over to me because they saw a bunch of traffic going to Apple. And if anything has to deal with Apple at Square, they pretty much come bug me. And they were like, we don't know what you're doing, but dear God, make it stop. And I was just like, okay, well, what's going on? Oh, 10.12.2 came out. Something is on fire. Okay, well, there's nothing really I can do about it right now. It's too late. It's too late. So we actually had to kill all traffic on the firewall to the 17 block. That was the only way. That was the only thing that we could think of to stop this from happening. And it was around lunchtime, whenever the updates came out. And whenever you kill the 17 block, nothing on the network works in terms of Apple. So we have like Apple Pay and stuff like that that we use around lunchtime. Nope. And we hit 99% on the firewall. That's the highest it's ever been. Pretty sure that gets an achievement unlocked on my part. Thank you, thank you, thank you. I didn't actually pause for dramatic effect there, but that was great. God, you guys are great. So some of you are probably thinking, whoa, caching servers. This solves this problem. This is why caching servers exist. So after that happened, why it was happening, that was my first thought is, well, we have caching servers. Like, why is this happening? And then so afterwards, I started digging, and I did a bunch of testing, and I noticed that any updates from the Mac App Store that you would want to download would come through the caching server. If you are on 10.11 and you went to download a software update to 10.11.6, it would come through the caching server. No version on 10.12 when trying to reach out for 10.12.2 would come through the caching server. It would always go directly to Apple. And we were like, well, this isn't good. So, I mean, we filed a radar since then, and, well, you know how that goes. No. Yeah, well, yeah. So we were like, okay, well, what are we going to do, right? When 10.12.3 comes out, this same exact thing is going to happen again. And who knows if it'll actually get fixed on time. So we're like, okay, well, we got to fix it ourselves. And so the answer, of course, is, well, let's deploy a software update server. And our favorite one would be Reposado. If you don't know what Reposado is, it's a open source software update server written by Walt Disney Animation Studios, which I believe one of the representatives is sitting back there in the corner. I won't make you raise your hand. I mean, it's okay. So we actually looked at deploying Reposado earlier, but we ran into a few issues that we didn't like. Things that we did like was we could get granular control over individual updates. So we could say whenever 10.12.3 comes out, we don't want it. And you can make separate branches of updates and apply them to different groups of machines, which is really nice if you ever want to like get into it and check it out. It's pretty cool. And it only requires Python 2.6, so you can run it on pretty much anything, even like a Windows server, but I don't know why you would want to do that. Things that we didn't like. At the current time, at the time when we first looked at it, it was our only option was doing it on the corp network. So if machines left the corporate network, Apple software updates wouldn't work, theoretically, and that was a no-go for us. And then when you wanted to add, like, oh, this group of people gets that new update, it was a manual promotion. Yes, I know it's on there twice. That part is twice as bad. So how the first thing that we needed to tackle was, okay, on the corporate network. How do we fix this? To the cloud. We can, so we just showed you that process that we had for sending all munki stuff to the internet. So that was pretty much solved. So we now have CloudFront that we can use. Manual promotion was the next thing to tackle. And I'm going to try and speed through this because I am way behind. How do we tackle this? Well, with automation. And this is where Jenkins comes in. So, handles that part. So these are the three tools that we had. We had Reposado, we had Jenkins, we have CloudFront. How do we tie it all together? So for the automation bit, we knew we needed to write something ourselves. And that's what basically Reposado is. It's something that can do auto promotion. So how does that bit actually work? So this is a basic example of what Reposado branches look like. So in this scenario, prod does not have any updates for iTunes or Safari. But testing has iTunes, dev has access to Safari and iTunes. And on the first run, it'll move anything that's in the testing catalog and move it to production. It'll move anything that's in dev to testing. And then it'll check to see what new updates that Apple has released, and then move them to dev. So that's all the first run. If everything's brand new and set up. Second run, Safari will move up, dev will move up, and that's pretty much it for the second run. And then the third run, we'll complete that bit. So in order to have munki run or do a force install of a Apple software update, you have to provide it information. And that was a manual process for us. But we thought, well, we're dealing with the catalog now, so we have direct access to updates. How can we leverage this? So Reposado loves munki just about as much as we do. So in the normal workflow, we put Reposado in there. So Jenkins will run Reposado on a cron style job. So we have it run 5 times a day between the hours of 8 a.m. and 5 p.m. And it slowly rolls it out across our fleet through those catalogs. So Reposado will run Reposado, and then Reposado will check Reposado to see if any of those updates that were just released requires a restart to be installed. So if that's the case, we know that it's probably something that we're going to have to force. So it'll take, if you want, you can set it to take that metadata and send it to munki. But so that was the first run. This is the sync run. So this is where the Jenkins looks at Reposado to see what was there, and then it'll send any of those updates up to CloudFront. And then the job after that, so once that job's finished, then it'll run another job. So you can stack jobs like this as much as you want. And it works pretty handy. So on the munki version, it actually looks at the munki repo that's on that same Jenkins box. And if there were changes to it, then it will take those changes, do some testing on them to make sure that everything's okay. And then it'll actually import it into the munki repo. Alrighty. We'll actually skip this Q&A. I will be around for beer. If you see me, talk to me. Next one. Something we call MOOCs, or how we do it internally, cowkins, or moo emojis, cow. Okay, yeah, tough crowd. So another issue that we had in terms of multiple people working on the same thing was for our licensed software distribution. So we were using Jamf Smart Groups, and it was really easy for folks to log into the JSS and pick folks for getting a new piece of software. When we moved to munki, munki's a lot of command line based stuff. There is some good GUI tools. But the best way I could think of to replicate this use case was to make an admin conditional, which basically says if it matches this conditional, which this is an example of a condition in munki. So if a user, which the first one is sketch, so we knew which conditional it was because you can't really name conditionals. So if any of these usernames, the current user, matched, then that user could get access to Sketch. So this is a plist file, and if 2 people around the same time requested access to Sketch and those 2 tickets went to 2 different techs, then they would try and modify this single line at the same time. And then we skipped that part. But to say the least, this didn't work very well. So basically, don't do that. We had a single munki manifest for the entire fleet. So, and we found out very quickly that that didn't work so great. And so, like, I talked with a bunch of different folks, and they were like, oh, well, we got to have all these multiple manifests. And my buddy Groob did a great blog post on how this works for a little bit more in-depth information on it. I highly recommend checking that out, which basically, the best way to do it is to make a manifest per machine. So basically, for a single piece of hardware, give it a list of instructions. But, so we have thousands of machines. And the reason why we didn't do this in the first place is because, well, manually making thousands of manifests sounds like a terrible idea. This is why we didn't do it in the first place. We knew that this was an option, but we were like, nope, it's not gonna work. So if we wanna make like a bunch of manifests, we need to have a source of truth for the information that we need, so we basically need a list of every single serial number that we have in order to do this. So we need a source of truth. And for us, we have a pretty decent asset management solution called Umitsa. For inventory, it works really well. When I actually went to take this screenshot, I noticed that they actually have our company on the list there. I actually need to report that because no company is supposed to do that. So we needed to figure out a way to make Umitsa, which has a great API, work with Munki. And to give you a bit of a scope on how we wanted it to work is, so say we have this machine, it's assigned to me, and assigned to me is Sketch software. So if I go to a new machine, we wanted to make it really easy. So I had this, the old 13-inch MacBook Pro, but then the Touch Bar came out. So got to make sure it works, right? Okay. So I got that. So I then assign, like a tech will assign me to the new hardware, which we actually automated that process as well. That's a whole nother talk. And then Sketch would follow me. It wouldn't follow the machine. It would follow me. This would make moving software a little bit easier. So this is what a manifest looks like for this machine. So basically, we made another manifest for every single person at Square. So at this point, we're at about 6,000 manifests. Doing that manually? No way. So this is hence why we're having this talk. So that manifest looks at my manifest, which looks something like this. And as you can see, in this particular shot that I took, I have access to parallels and windows. Why, I don't really know. But so this is what the hierarchy looks like for the actual Munki repo. So the first level is where Munki will look for the initial manifest, which is the serial number of the machine. And then the included manifest, as you saw previously, sat in users/west. So that's basically saying, look at this directory on the server for that manifest. So that's how that bit works. So this tool, Jenkins, runs, it looks at Umitza, and it pulls down basically a list of all the machines that we have that are Macs and who their user is, who it's assigned to. And we build a local database of sorts. And then it looks for a change. If I got a new machine, Jenkins would notice that I got that new machine, and it would trigger another job. What that job does is then takes that information and injects it into Munki. And that's where you get 3,000 serial numbers manifests that then have a included manifest for 3,000 user manifests. It's a little complicated, but Groob's post that I mentioned earlier does a really great job of explaining it. I highly recommend checking that out. And so, as you can probably guess, Munki plus Umitza plus Jenkins gives you Mookins. This one I might actually take questions on because I do have a decent amount of time left still. Anybody have a question? Sure. All right, here we go. Oh, nailed it.
Whoa, good.
Sports.
Your monkey repo with its, so I'm guessing you have 6,000 serial numbers in
So
the top level, and then a user with every user under that?
So,
You had it really abbreviated, but it was,
yeah. So, so you have like monkey repo, then manifests. So inside the manifest directory, we have a manifest with the name of every single serial number that we have.
And you just use the Apple serial number.
Yes.
Okay.
And then in order we wanted to make it somewhat legible. So that's why we took all of the user manifests that were named after users, and we put them in the directory users inside of manifests, if that makes sense.
Yeah, I didn't know you could do directories in manifest.
I didn't either until I went to try it. And then I was like, hey guys, is this possible? And they were basically, I don't know. I don't think anybody's ever done it, but if you get it to work, let us know.
Well,
So-
no, I mean, I like it because
Yeah.
I just work with small offices. An office of 20, 30 machines
Yeah.
has over, a couple hundred entries
Yeah.
if it's a flat file directory, a flat directory.
Yeah, this helps a lot with finding out where things are. Right behind you, by the looks of things.
So are the Mookins and stuff available on GitHub, or is it intellectual property that's not shared?
So so this was really unique to Umitza, and we had no idea if people were using Munki and people were using Umitza and they wanted to do something like this. There is a guy on my team who actually wrote most of this. His name is Poxonus on the Slack GitHub, Poxonus or something like that. He'll have the little square insignia next to his name. Message him and tell him you want Mookins open sourced. Anybody who wants that, I highly encourage you to do so right now, even if you want it.
Could you spell it again?
POX.
Okay.
And then I can't imagine there's a ton of POXs in the directory there. Should see the square logo, it's the square icon.
Okay.
Yeah, message him, make Mookins open source.
And the other scripts that you've been referencing within Jenkins, do you have a document write-up somewhere?
So Mookins will basically be a script that just you run with Jenkins, and then that's it. Like in that build window that I showed.
Okay.
You just put it there and run it.
Yeah, and so Repotati.
That is actually in the process of being open source.
Okay.
Hopefully tomorrow I'll finally have it out. It's been sitting in the queue to go out for like 3 weeks now. So.
Okay, we do a very similar process at the University of Illinois, but we're not quite to this level. But we use Jenkins, and we've got stuff scripted, and we don't have Reposado scripted yet.
Cool.
And so either I'll be following your footsteps, coding it myself.
Yeah.
Or
No, it's all ready. It
Okay.
just needs to hit the publish button and we're good to go. Anybody else on this guy? hopefully this is somewhat understandable and consumable, I suppose. No? All right, shall we continue? Cool. This next one is we're really excited about. It's still like early in development, so bear with us. But we call it Munki CI. So for this, we wanted to fully test any changes in Munki in any environment. So whether that environment be the standard use where somebody's using it on a day-to-day for their job, or it's a install that will eventually be run at the login window. Certain apps work differently when they're installed at certain times, as I'm sure you're aware. And then we also wanted to make sure that any install worked during imaging or soon to be DEP. So this is the overview for this. So whether it's autopkg or whether it's a developer, and they make a change and they push it to GitHub or Git server, Git server then forwards that to Jenkins, and then Jenkins forwards that to this guy. Does anybody know what that is? Yeah. So you say Anka, I say Anka. I don't, well, yeah, who knows how it's actually pronounced. So it's a tool made by these guys, VR2. This just came out, and it is awesome. Or, well, were you shaking your head? Oh, how awesome it is, yeah. So basically, they built macOS, they containerized macOS pretty much into virtual machines. And they made it for iOS folks. So if you can do it for iOS, you can do it for different Mac stuff, right? So virtual machines, right? Mainly from the command line, and it's all drivable by Jenkins. They made a Jenkins plugin.
Wow.
So this is how it works. The CI system, which would be Jenkins. This is them, by the way. I didn't make this pretty thing, as you can tell from my previous work. So it sends it to the Anka controller, which then can look at the registry of available updates if you know, or of available containers. If you know which VM you need, then it'll pick that VM from the registry and then send it to one of the Anka nodes. And then from there, you can do all the tests. So basically, we can have a VM that's ready to go at the login window. We have a VM that's ready to go whenever you're ready to do like an imaging or a DEP process, or we have one that's just sitting at the desktop like anybody was using the computer. And then we can actually do full Munki tests on those boxes. So Jenkins will look at the commit, and it'll find if, say, Chrome was changed, it'll find that Chrome was specifically changed, and then it'll create a manifest on the fly, a local only manifest if you know what that is in Munki. It basically says look at this manifest that's on the machine already. You don't have to look at the server, and say okay, install Chrome, run it again, and if Chrome has to be reinstalled, then we failed. If Chrome is installed and it's not trying to install it again, we've passed. We're taking that as a baseline good test, or if Munki actually reports that something failed, like a post-install script failed, or the package actually failed to install, period. We can take that look at it and we know how it went. So if it passed or it failed, in this particular case, if it failed, it lets us know that this unique process failed, or this unique change failed. if it passed, this is the continuous deployment part. If Jenkins says it passed, awesome, ship it. Then we go back to the sync workflow, right? This has been awesome with autopkg. We haven't imported a package into Munki in about 6 months. It's fantastic. I have so much more pub time. Ask Graham Gilbert. We are so much better friends now. Any Q&A on this guy? I know it was a little short, brief overview of the potential for this. Sure.
So, do you do any Windows patching this way?
Windows patching?
Yeah. So there are autopkg recipes for Windows. Have you, as far as with Anka, have you tried doing that with Windows?
We
or anything?
have sub 20 Windows machines, and so no, not yet. But when we get a Windows team together, which we're actually going to be hiring for that pretty soon, if you know anybody, or if you want to do it, let me know. Kind of the wrong crowd for that job, but yeah.
Where would they be living at?
San Francisco. It's not that bad, guys. Okay, it's just really expensive. Yeah.
You can just say, hey, I'll find this and we can talk about it later. It was about your Anka deployment and getting that set up on a fleet of nodes. What were you using to deploy that on machines? Were you using Munki to deploy that tool on those machines that you then used to?
Yeah, no, I know exactly what you're talking about. Anka is like really new, right? So we just started, and don't tell anybody, but we use SaltStack for config management on Mac OS. We just started playing with it. We love it. The Puppet guys, the Chef guys, they'll get all upset if they find out about this. But I guess cat's out of the bag. But so yeah, we use SaltStack to do all the orchestration, or we're going to for all the orchestration on this.
And then can you just, since it is so relative, I think the beta 40 or something just got dropped for Anka. Like, how stability wise, have you had really good experience with it? Or?
I haven't. I've been on vacation for like the week and a half before this, so I probably didn't even see that release came out. So I haven't.
No, I just mean in general with it being so new. Stability wise, are you satisfied with it?
So far, from what we see, and if we do run into issues, their Slack channel, Veer2 on the MacAdmins Slack, they're super responsive. They're really happy that people are interested in this in general. It's really great. I highly recommend taking it. Even for just normal virtual machine stuff, incredible. They've got patent pending like VM or like start times. It takes like 2 seconds to start a VM. It's super great stuff. All right, anybody else? Questions? This is where I'll let statements happen, but it will cost you a beer. No? No? Well, okay, well, that's it. That's all I got. Okay, thanks.